Now, on the S4 sponsor stage is the session from Cisco. Please welcome IoT Security Portfolio Manager Robert Albach to the S4 sponsor stage.
Thank you. Yes, there are lights. Not a whole lot of you here. Quick question. How many of you are not from a vendor? Almost half. Excellent. Very good. So my name is Robert Albach. I'm responsible for our industrial security portfolio at Cisco. And I'm going to primarily be focused, and if any of you are salespeople from Cisco, my apologies, there will be only one slide mentioning any Cisco products anywhere. All right, so apologies for that. Primarily because I'm a bit of an old school security person, which means it's really more about process versus the products. What you guys do with it, how you actually implement them is going to be much more important per se than the individual thing that you're going to actually go out there and deploy. One other note, at the very bottom, you'll see my email address. That is there purposely, meaning I wouldn't have put it out there if I didn't want to hear from you. So if anything that I say doesn't ring true, or you've got particular concerns about what I'm discussing, then I'd like to hear from you. But either way, it's a chance for me to learn from your particular situation and what we can do to basically help you in that first. So I see somebody's kind of writing that down. And wait just a moment. Plus, by the way, I can just give you a business card afterwards. All right, so we'll advance a little bit here. What is the vision? This is the big vision of the World Industry 4.0. This discussion will primarily be manufacturing centric, although there will be a few examples that will be more apropos to the utility world. And we have this wonderful design model here in this wonderfully German compound noun equivalent, reference architecture model 4.0. But the big picture is this. This is about product going all the way to the connected world. And by the way, I'm happy to give you guys this presentation so you don't have to take pictures of every screenshot, okay? So just to make your life easier for you. But the point here is if you look at the lower right of this slide, you'll note it's got product all the way out to the connected world. And from our perspective, that's actually the life cycle of what we're dealing with. So increasingly, it's not just about the supply chain, it's actually about the post-production life of that thing after it actually leaves the factory. So again, from our perspective in the organization and talking about boundaries, we're looking at from all the materials, raw materials, plans, and so forth that go into what are we gonna build and how are we gonna build it to the point of we've now built it and it's now left the factory, it's now left the inventory state, it's now out at wherever it might be. And we think that you really are going to have to be able to track things, depending upon the nature of what you're building, from that raw material state all the way through its usage and potential life cycle in the customer hands. So this is quite a bit of a departure. If you're not aware, we actually have some Cisco security that's going to start shipping in some cars starting this year. And we're actually looking at when that car leaves the factory, what is going to be our interaction with that car after it leaves the factory. Okay, so what's this question I'm really focused on? Boundaries. What are the boundaries for securing the creation of that product all the way through that product success out in the real world? Okay, we click the green button and things going. All right, so just to expand on this and get it closer to the actual organization itself, from the cloud to the enterprise to sell. The basic story here is this. People want to get information from the process, basically on the factory floor or substation, whatever the place may be, up to the top of the control environment, the factory side, if you will, potentially across the industrial DMZ into the enterprise where I've got my MES, ERP systems, and then potentially out to that cloud world, you know, your Predix, your MindSpheres, whatever the case may be out there. How many different technology boundaries are you going to cross, and how many different organizational boundaries are you going to cross in that process? And you actually can say, yes, we've got everybody involved in each and every boundary involved and coordinating together to ensure that everything's going to be secured. So this is not just a, how do I discover this particular asset on this particular point in this particular cell? This is a, well beyond that, how are we going to get all of this thing connected so that we're going to realize those grand visions of improved operational efficiency and agility and all that other kind of good stuff that you're going to hear from the industrial pundits around the world. So let's talk first about one of these examples, of course in a utility context, about boundaries and boundary issues that might arise. No doubt most of you are aware of what happened in one of the, and this is actually the first Ukrainian utility attack that took place. This is actually a video that was captured, and probably one of those first boundaries that is, if you look in the, if you watch the video, you can go to wired.com, by the way, and actually watch this video. It's pretty entertaining. So the first boundary I actually focus on is, in some respects, a generational boundary. You've got this older, wizened operational guys kind of giving a blow-by-blow of what they see here. Of course, this is an HMI, and they're locked out. They can't do anything about it. And then you've got the young guy who's actually recording it on his iPhone. Because, of course, it's the young guy with the iPhone who thinks to record the thing, right? And you've got this kind of deep voice going, oh, yeah, they're switching these breakers. They just turned off the electricity, this. And then the young guy gets all strident. He goes, oh, my gosh. We got to tell the IT guys about this, right? And, of course, then the old guy, whoops, that did not build. The build did not work. Okay. Anyhow, so the young guy said, and then the old guy goes, well, what if it's the IT people that are actually doing this? Okay, so there's one of your boundary conflicts right there, right? You've got your OT group and your IT group not really trusting each other there. You've got the old versus the young. The old guy doesn't even think about contacting the IT guys. The young guy does, right? So these are, to some degree, some of these organizational impediments to potential operational improvements and security improvements that we can go along with here. Dale Peterson, the gentleman who is sponsoring this, wrote this particular blog where he asks the question, what's the best raw material for an OT security team? Now this was very helpful for me because I actually submitted the title and focus of this talk 2 weeks before he wrote this, so it was very nice of him to do that. But it's a legitimate question with regards to who is the most appropriate set of people to go in and secure these particular assets. All right. All my builds are going to be destroyed here. I wish I'd known this. So one of the things I thought to do was to go in and take a look at the curriculum to create a chemical engineer. All right. And now, this is particularly valuable to me because when I got married, my wife was a teacher, and about 18 months in, she said, the heck with this, I think I'll become a chemical engineer, which was cool. But this is what she went through, all right? Interesting things, and I thought, let's just go back and look at, here we are, 2018, what does that curricula look like today? So there is 2 hours of introduction to computing, and that's it. Now, you have to have 50% more of that in world literature to graduate, okay? So the amount of compute emphasis here in the OT space is less than the world literature emphasis. Now, I'm being a little bit unfair here because in the process of being a chemical engineer, you're actually going to have to go in and do some programming in certain places, but not a whole lot, okay? So the big point here is, in that argument about the OT people versus the IT people, the formal education with regards to system security does not exist in the curriculum, full stop, okay? Now, I'm the IT guy, she's the OT person. We mostly get along all right. We've got 3 kids, production's okay, quality's up to, we'll see over time. But basic point here is, who's really in that position to take on this role, okay? And that's part of what Dale's point is. Who is really the folks that are out there and ready to take on this role of securing things? So 2 years ago, I did a survey of 600 people within our Cisco world, and we asked the question, who owns industrial security? All right, and it was pretty evenly among those who said, I can give you an answer, and it's like, the OT team owns it, the IT team owns it, and then, frankly, we're still trying to figure it out. All right, that was 2 years ago. In our experience, not fully backed up by metrics, we're seeing a lot more growth on the IT side for a lot of different reasons. And a lot of it had to do with some of the incidents that happened in 2017, which we'll talk about here. So one of the first things that we also look at, and we always have this question, when someone asks me, hey, to come talk to this customer or whatever, I'm always asking, whom are we speaking with? And then we want to understand what are their responsibilities. And it's almost always it's in flux question. But I want to understand often what are the technology stacks that are at play, and then who's being held responsible for them. So again, we're using the same image. On the far left, we've got our cloud and the outside world, the cloud known as other people's servers. And on the far right, we've actually got the factory floor, where we've got your different cells and different machines at play here. I take the purple bits, that purple box, and I say, this is primarily OT unique technology that's at play here. All right, some of the stuff that's been out there for decades, the things that my wife would, as a production engineer that she was for some number of years, was responsible for. In the blue, we've got what looks like effectively an IT technology stack. Okay, Windows and Linux servers. If it's a Windows box, we're talking about Oracle databases, Microsoft SQL Server, possibly DB2, even .NET applications with .ASP interfaces. Okay. And effectively, what controls what's in the purple bit, okay? Factory Talk is a Microsoft application, if you're not aware already, okay? The question is, where in my wife's curricula did she cover Microsoft SQL Server database administration? The answer was no. She has no idea that there's a Microsoft SQL Server underneath the historian which stuff just happened to go to there. So how can we ensure that the different organizations with skills and responsibilities are aligned with the technology that underlines the operation of these environments? And this is where we often see a little bit of problems that arise. And this is where some of the things have actually changed. So, classic example, Siemens WinCC. The first three letters of WinCC are not random. This basically means Windows. And then here's all the platforms. You've got Windows 7, 8.1, 10, Server 2008, 2012. It's a Windows world. OPC, not a lot of people want to say this, but the O in OPC used to stand for OLE, Object Linking and Embedding. That's a Microsoft DCOM-based technology here, okay? It is a Windows world at the top of the factory. At that control layer, even in the utility space as well. Windows is an IT standard platform. Full stop. Anyone familiar with Snort? Some of you guys? Good, excellent. Snort, open source intrusion detection or intrusion protection, if you're taking actual actions on it. Basically run by SourceFire. SourceFire acquired by Cisco some number of years ago. We got different class of products out there. All of these things that we're listing here are essentially rules associated with industrial environments. So we've got Mitsubishi, Siemens, Schneider Electric. We've got something focused on BACnet and OPC, General Electric, and then specific protocol controls here as well, IEC 104 and other types of things. Notice highlighted in yellow, we kind of classify the vulnerabilities or the focus of the rules. Only a few of them actually say protocol SCADA. For example, the Mitsubishi rule is a browser plugin. The Schneider Electric rule is a web app rule. The point being, these classification of vulnerabilities and thus their protections are primarily or most frequently associated with a standard IT class vulnerability set. Okay, so again, we get back to what's the nature of the vulnerabilities that are out there, and what's the nature of the protections, and who actually has knowledge and understanding of an ActiveX plugin. Okay, again, my wife never studied ActiveX protections when she was doing her chemical engineering work. Okay, so again, organizationally, the question is, who has the best set of skills and potentially access to tools that understands these particular vulnerabilities? We often over-rotate on the sexiness of I have some kind of unique, funky platform that I'm really worried about here, versus really digging in on what's the nature of the risk, and then what do we need to do to be able to secure against that risk. All right. Okay, so let's give a few incident examples. Everyone wants to focus on incidents. So let's talk about cloud impacts to OT systems. How many of you can name a cloud-related incident that shut down operational technologies for the last 2 years? No hands going up. All right. April 2018. Some very bad headlines. First, insecure SCADA systems blamed in rash of pipeline data network attacks. There was no touch of any SCADA systems, and there was no pipelines specifically touched. Number two, cyber attack pings data systems of at least 4 gas networks. How many emails did I receive from crazy people in the field asking me about ping attacks on pipelines? Many. How many actually took place? 0. All right. And then finally, MRT. Who is MRT? This is the Midland Republic Times. Anybody know where Midland is? Texas, good. Are you from Texas? No, I'm from Texas, so I know where Midland is. Okay, Midland is in the Permian Basin. That's this reservoir of gas and oil, which straddles the New Mexico-Texas border. Right in the heart of it is Midland, all right, which you might possibly know more importantly for some of you is that was actually where the whole Friday Night Lights thing came from, all right? So we either do football or gas out in West Texas. They got it right, okay? Cyber attack shuts down any transfers pipeline data system. What actually happened here? 4 pipelines were shut down because electronic data interchange between the customers and the providers was basically hacked. There was no visibility with regards to the state of the consumers downstream from the pipelines. And as such, they couldn't set pricing, and they actually didn't sure whether it's safe to continue to shove, product to these particular places down below. So pipelines shut down actually because a subcontractor of a cloud-based electronic data interchange was actually hacked. So question to you, when you consider your threat modeling, how many of you, if you happen to be in the pipeline area, are thinking about the whole supply chain piece of subcontractors that you never heard of working for somebody else that's actually exchanging data? Point being, organizational considerations, think broadly with regards to all the systems that you have dependencies on, and then try to understand the componentry within, and then whom are they actually depending on. All right, another incident, enterprise remote access, something which is generally going to be handled at your enterprise, hopefully DMZ, to the outside world. Probably one of the earliest known attacks that took place, Salt River Project. Salt River is it's in Arizona. Yeah, okay, the big hint there. But the point thing, what happened, it was effectively that you had some external people actually employed by them that got into it remotely, but there was no real access control about, yes, you're the IT guy, and yes, that's an IT system, but they went in and they started messing with some things and caused a minimal amount of problems there. But this is a classic remote access into the wrong assets question. All right, hey, 1994, no doubt we've got that fixed. 6 years later, we have a very similar situation with Marucci Shire, in which you've got a contractor responsible for care and feeding of a sewage system environment. Person gets unhappy, comes in, messes with some things. Again, this is really about remote access control of contractors and even subcontractors of subcontractors, right? Personal little note here again, my brother is a subcontractor to other people. He likes to do his work from the local library. Right? He shows up, basically the library hours is his working hours. It's the way he looks at it. They kick him out, then he stopped working. But the point is, from there, he goes into the contractor group that hired him. He then goes to the primary contractor using their credentials and gets onto a factory environment and contributes to the ongoing care and feeding of some key systems there. There is no way the people who run that factory have any idea who that person is who's actually going in through multiple shared credentials to get to this particular place. Okay, who's responsible for that? Right, that initial login, and are you actually coordinating with them? All right, so that was what, 2000 whatever, now it's 2016, and we've got the Department of Justice bringing along a former sysadmin who gets fired, and he gets drunk, and he uses the same credentials to once again reach directly into the factory environment and gain access and cause problems to some equipment. All right, this is a standard IT control issue. Who's actually responsible for saying you can get into the company, right? The person was fired. HR should have contacted everyone and anyone associated with network access and cut off all those credentials, right? Perhaps more importantly, they should have said, let's do an analysis of who's dialing in and find out whether there's shared credentials being used in this dial-in process. None of that is OT unique, all right? But who's actually responsible for maintaining that? Okay, again, this is one of those questions of who's best positioned and who should be responsible for these environments. All of these impacts, again, are operationally impactful. None of these issues are actually OT unique. These are standard IT issues. All right. VPN filter. This was something that our folks, Talos, if you're not familiar with Talos, that's our security research arm here inside Cisco. They're the folks who actually discovered the MEDOC bit, right? MEDOC was that Ukrainian accounting package. They're actually the ones who figured out exactly how that stuff injected. There was another project here called VPN filter that they also discovered. 500,000 network devices around the world, primarily routers, the kinds of things that you might find at a remote environment, such as a small municipality's water filtering place and such. And buried deep within there was a simple, tiny little module which said, if we happen to see this particular port communicating, feed that information back to the mothership. And that port was basically for Modbus. Now, there was no explicit code in there to take advantage of it or anything to do it, but at the same time, this particular thing, and it looked like it was actually added a little bit later, as in they built out the malware so that they could actually place within these environments. And then it just, as long as we're in there, let's listen, and let's just start listening a little bit for Modbus. Okay, so 500,000 network devices that we actually identified, and they're out there listening for Modbus. Okay, who's responsible for that internet-facing router operation and security? Possibly, it might be the operational teams who may be responsible for communications with that particular equipment, but for the most part, this is an IT class of responsibilities. Router maintenance, router security. It just happened to have this tiny little snippet of code in there, which actually was looking for Modbus and reporting back to it. Okay, who is in the best position to go off and take care of these things and understand that? Now, clearly it's going to be the OT guys who are going to say, hey, port 502, boom, we should have a concern about that, but everything else associated with what that activity is going to look like in IT discussion. Okay, generally speaking, again, we like to do a lot of math, we like to do a lot of investigation. Most attacks on ICS systems basically come from the IT side. If you're not familiar with the kill chain, some good folks defined this and expanded it. Things mostly start from the IT side. Okay, things that go off and modify, like a Triconix sys system, came from a Windows-based workstation. Okay, fair enough. So again, do we have coordination? Do we have policies that are being developed jointly from that IT side over to the OT side? Are there potentially shared credentials from the people in the operation side that might have access actually invert that, from the IT side to the operation side? I mentioned my wife earlier, chemical engineer. She was a manufacturing engineer in terms of actually product development. Okay, so she developed the processes which were going to be applied initially at a pilot plant and then actually proved out there. She did not work in a factory. She worked in a research center, and that network was essentially the IT network. Okay, she would have been a wonderful target to go in and say, hey, Mrs. Albach, my wife, here is the schedule for the kids' soccer tournament that's upcoming, because it just so happens her name, our kids were associated with this website, which talks about the upcoming soccer team activities. Here's the schedule. You should open this out and figure out what you're doing this weekend. A great phishing attempt. A lot of these things start with phishing, classic IT techniques to gain access to someone with the shared credentials on the IT side to make their way over. Somebody should be working together to understand who has those shared credentials. Okay. It's probably not going to be the OT folks because they're over here in the factory. They're not really going to know what's going on the IT side, and then vice versa. All right. So there has to be coordination. There has to be understanding where these boundaries exist and what the nature of those boundaries not sharing information might mean. All right. Classic example, the attack over on the smelter over in Germany started with phishing. If you could read German, I suggest you take a look and download this report and see what's happening there. And we try to advance. I mentioned before that there's been a big change with regards to who's going to be responsible for certain assets and activities. This incident was probably the primary point, because these 5 people basically lost about $2 billion, and it was all because of a vulnerability MS17-010. The MS stands for Microsoft. Everything touched was a Microsoft platform. Okay, again, who is in the best position to understand the vulnerabilities associated with Microsoft platforms and how you go about protecting them? One of the reasons we see the big changes. And then finally, this wonderful point of remote access. Somewhere out in the cloud or somebody else's network environment is the tech. That tech needs to go across the internet, across the enterprise DMZ, across the core of the network, across the industrial DMZ, and gain access to one particular assets that they're actually in a position to do work on in this factory environment. It's the ABB technician who has to deal with the ABB pump. He should not be dealing with the FANUC robot, right? Do we have policy that can actually trace their path all the way from that laptop sitting hopefully in the ABB headquarters all the way down to that asset? Think about all the different organizations you have to cross to make that possible and viable. And of course, here's the one product slide here. I'll just make the mention from a Cisco perspective. We basically think from those devices, from the point that you connect that FANUC robot or ABB pump into the network down there, all the way out to that remote laptop, we think we've got you covered. All right, so this is my one product slide here, all the way around. And the biggest point here more than anything, align skills and responsibilities. If it looks like an IT technology, you should probably let the IT folks handle it. If it doesn't, let the OT folks handle it. If you're uncertain, cross-train. Even if you are certain, you should probably cross-train anyway. And in all events, cooperate as much as possible.